Next, we're going to use quadratic problems functions to solve problems involving maximums or minimum values. So remember that the vertex of a parabola with a leading coefficient that's greater than 0, so positive, is a minimum, and the vertex of a parabola with a leading coefficient that's negative is going to be a maximum. So let's say David has 400 yards of fencing and wishes to enclose a rectangular area. We need to express area of a rectangle as a function of width, which is going to be the width of a rectangle. Well, I know I've got 400 yards, and if I take away 2w from that, I will have 400 minus 2w, and that's going to be the side of both lengths, so I need to divide that by 2. So that means my length is 200 minus w. So now if I wanted to write area as a function of terms of w, remember that area is width times length. So A in terms of w is w times 200 minus w. So A of w is 200w minus w squared. So A of w equals negative w squared times 2 plus 200w. So this parabola has a negative leading coefficient. It's going to have a maximum because it's concave down. So I'm trying to find for what value of w would my area be the largest. So I need to find the vertex. Remember, our vertex is HK, where H is negative b over 2a, and k is f of h. Well, in this case, a is negative 1, and b is 200. So, for what value of w, remember this is w, area of w, I'm trying to find h. So h is negative b over 2a, which is negative 200 over 2 times negative 2. So I have, negative 1. So I have negative 200 over negative 2, which is 100. So for an w is 100, my area is going to be the largest because that is the x-coordinate of our vertex. So what's the maximum area? Well, I'm going to find a of h, which is going to be my k, my y, my output, which is going to be a of 100. So I have negative 100 squared plus 200 times 100, just substituting in to my original equation. That gives me negative 10,000 plus 20,000, so 10,000 feet. So if I have 400 yards of fencing, when my width is 100, that's when my area is going to be the largest, and the largest possible area that I could have is 10,000 feet. This problem is similar to the last one, but a little bit different. So a farmer with 200 meters of fencing wants to enclose a rectangular plot that borders on a river. So now I only have to worry about fencing on 3 sides. If the farmer does not put fence along the river, what's the largest area that can be enclosed? So I've got 2 x's, right? These 2 lengths are the same. And then I have to figure out what's left over. Well, I've got 2,000 meters, and if I take away 2x, that's 2,000 minus 2x. So I can define my area. A of x is x times 200 minus 2x. So A of x is 200x minus 2x squared. So A of x equals negative 2x squared plus 2,000 2,000, not 200, 2,000 x. So I need to find my vertex, right? This is a parabola that opens downward. This point's going to be my maximum, where it's going to be my largest possible x, and therefore the largest possible area. This is the point x, ALS. So h is negative b over 2a, and k is f of h, which in this case would be a of h, because we're working with area. So h is negative b, which is 2,000, over 2 times negative 2. So I have negative 2,000 divided by negative 4. That gives me a positive 500. Now I'm trying to find a of h. So I have a of 500 is negative 2 times 500 squared plus 2,000 times 500. That gives me negative 500,000 plus 1 million equals 500,000. And remember that my fencing was in meters, but its area, so it's meters squared. So the largest area that can be enclosed is 500,000 meters squared.